right, welcome back. Let's look at this question. We have a circle, we have a cyclic quadrilateral, and definition of a cyclic quadrilateral is a quadrilateral that has all the four vertices on the circumference of a circle. Is called the cyclic quadrilateral. All right. Reminder, if you can remember, but cyclic quad has got some angle properties, and one of the ones that we're going to use is that is the opposite angles in a cyclic quad, the opposite angle. So there's one angle here, 2x plus 40 degrees, and this one is x plus 50 degrees. Opposite angles in a cyclic quadrilateral, and so as angle I and angle J. So the opposite angles in a cyclic quadrilateral are supplementary. So in this case, we need to solve for angle X and angle C. First thing we're going to do, we're going to write up what we do know, and that is we know that X plus 50 plus 2x plus 40 degrees, they must add up to 180 degrees. Now, x is a degree, whatever that degree is. We don't know what that is, but we have to solve that. Well, this is just adding like terms. So 3x plus 90 degrees equal to 180 degrees. So isolate 3x equal to 90 degrees. We're subtracting 90 from both sides. So x will be equal to 30 degrees. That's the value of x, which is right there. So that is 30 degrees. Right, now that we have x equal to 30 degrees, we want to find what angle C is. And angle C is this entire thing. So 2x, so angle C is equal to 2x plus 40 degrees, but x is 30, which is right there. So 2 times 30 degrees plus 40 degrees, and final answer 60 degrees plus 40 degrees, that's equal to 100 degrees. That's the measure of angle C. All right, I hope this was helpful. I do suggest you do a lot of practice with this theorem and all other theorems within the cyclic quad, including exterior angles as well, and keep at it. All right.